All right. Good day, everyone. Good morning, good evening, wherever you happen to be in the world. Thank you for joining me today. We're just going to, before we get underway, we're just going to give it one more minute for people to come in from the waiting room, and then we'll get going. I can see we've got quite a few people waiting to join us, so we'll just give them 1 minute. All right, I think that's everybody who was in the waiting room. Everyone else is going to have to join us later. So once again, thank you everyone for joining me today. My name is Alex. I am the head of product and development for DBVisit Software. Thank you for joining me today. We are going to be having quite a short session today, and it's going to be all about our latest release for our Standby multi-platform product, version 12.3. It's got quite a few interesting technical aspects that I want to cover with you today. We're going to keep it short to about 30 minutes. If you do have any questions as we go along, please do put them into the QA channel. There should be a button towards the bottom or the top of your screen in Zoom called QA. Please post it in there. And then once we get to the end of the session, I'll do my best to answer any questions you have. Let's get underway with no further ado. So just before we get into the specifics of our latest release, I just wanted to very, very quickly cover where we're coming from as a company and what our product is all about. We're only going to spend a couple of minutes on this, just for those of you who may be new to DBVisit and new to Standby multi-platform. So we are database disaster recovery experts. We have been for over 20 years now. Database disaster recovery is the only thing we do, and we'd like to think we do it pretty well. About 1,700 customers all around the world agree with us. I think it's actually 1,800 now. And we play across SQL Server, Oracle, and Postgres. So we're originally from the Oracle world, and a relatively well-known name there. And we've expanded into SQL Server and Postgres a few years ago. SQL Server is a big commitment to the company. So our SQL Server business has grown 300% over the last year. And this release 12.3 is all about us making a greater commitment to SQL Server and moving towards making the product suitable for large-scale enterprise deployments. But we'll get onto that in a moment. One more marketing slide, 96% customer satisfaction. I think it's 97% this year, actually. So people do like dealing with us, which is good. And what our product is about is ultimately it's about real-world disaster recovery. Now, there's many ways to protect your database. There are a large number of options out there for any database platform, and SQL Server included, to do disaster recovery. They tend to all promise a lot, and then when disaster actually happens, usually at 2 a.m. on a Saturday, the reality sometimes differs from the marketing. So what we do is we would like to think that our product is designed for real-world practical use, real-world reliable use. We may not be the most complex product out there, but it's a product that actually works, actually will save your database when it counts. In the 20 years in the industry, we've kind of learned that most of the real-world issues don't often have to do with some sort of very complex, advanced technical matter. It's usually a real-world complication. It's usually, a difficulty in timing. It's a difficulty in clarity of knowing what to do, and a difficulty in decision-making. It's a difficulty because you were attacked, because there's been some malicious action. It's a difficulty because you've experienced some sort of hardware failure or some event that you can't easily predict. And in those situations, what's most important is that you've got the clarity to know what to do, and you've got a very quick pathway to doing it. And those are the two things that we focus on making things very clear and fast, and on allowing you to do things quickly when you need to. So with that out of the way, let's talk about 12.3 specifically. So the 12.3 release of Standby Multi-Platform, which is our disaster recovery product, is basically all about SQL Server. And it's about SQL Server in general, and also about SQL Server across large-scale deployments. So when you've got dozens, even hundreds of databases simultaneously that you're dealing with, even potentially hundreds of instances that you're simultaneously dealing with. And it's a very different world, as I'm sure those of you who have dealt with large-scale deployments will agree with me. It's a very different world when you're dealing with a couple of instances and when you're dealing with 100 instances. You know, the types of problems and the types of workflows are completely different between those two circumstances. And with this release 12.3, we've really focused on making Standby Multi-Platform suitable for large-scale deployments, getting it to a point where it's performant and its error reporting and its kind of edge case protection is good enough to be used in enterprise environments. So the most of this presentation today, I wanted to take you through a few examples of that. You know, but this is we've focused on certain technical aspects of the product. So I wanted to tell you about those aspects very specifically and what we've done. And right at the top, we've really improved the way that we deal with memory consumption. So the way that our product works underneath, kind of under the covers, is every component of dbVisit Standby Multi-Platform has a little product repository, and it's usually a SQLite database. This has got nothing to do with your databases. This has nothing to do with your SQL Server database that we're managing for you. These repositories contain configuration and logging and various data that our product uses itself in order to work. And what happens is when you start up all of our various components, they auto-announce to each other, they connect to each other, and then they share this repository data. And what used to happen is, in order for us to send this data down the network between components, we would take these repositories and we would load them fully into memory. Now, in the vast majority of cases, if you've only got a few configurations, maybe you're dealing with 2-3 instances, those repositories never really get very large. They contain, as I said, they contain configuration data. It's mostly text, so it's easily compressed. They contain some information about your environments. They contain some networking information. They're not huge. And so typically this doesn't have much impact on either your network or on the memory consumption on each device. However, when you're dealing with large-scale deployments, especially large-scale deployments that have been up for an extended period of time, if you've got 50 instances that you're dealing with, and our product has been installed and running for years, these product repositories can get quite large. And what we're finding is that because we're loading them fully into memory in order to share them with other components, during service startup, we could potentially occupy really quite a bit of RAM. This is not something that you want to see. Obviously, you don't want to see a big memory spike when you start a service. So we've remediated that, and the way we're dealing with this now is, instead of loading the repositories fully into memory, we're loading them in small chunks, only as we need to share them down the network. And what this means is that even if you have a very large deployment, for example, if you're using our control center, those of you familiar with our product, if you're using our control center to manage 200 configurations, when you start up the control center, the memory consumption really doesn't increase all that much, because we've now introduced this logic to manage that and only load it as needed to send down the network. As soon as a chunk goes down the network, it's unloaded from memory. Another good change we've made is limits on instance operations, on simultaneous instance operations. So SQL Server is a little bit unusual among databases in that you can have really any number of databases within an instance, right? In the Oracle world, a database kind of sits on its own. We can talk about pluggable databases, but there usually aren't that many. On SQL Server, however, you don't not only can, but you're really quite encouraged by Microsoft to kind of have as many databases as you want. They're almost treated as table spaces in a way. And but our product it acts on the database level. So if you've got 100 databases in one instance, and we do have customers that have that, you're potentially doing actions across 100 databases at the same time. And what we found is that if you try to do a lot of parallel actions, if you select 100 databases and basically, for example, issue a backup command across all of them simultaneously, the way SQL Server itself works has got nothing to do with our software. The way SQL Server itself handles the prioritization of those queries, of those actions, can be a little bit unpredictable depending on various factors that we don't need to get into here. And you can create bottlenecks where the instance itself doesn't manage that very well. And previously, we just allowed SQL Server to make up its own mind. If you want to select 100 databases and do a backup on all of them, we just ran those commands. But what we found is that if we introduce a limit from our side and we don't give the instance too much at once, we're actually able to get much more performance out of it. So that's exactly what we've done. We've set the limit to 10 by default. That means that any one instance, we only allow 10 concurrent actions to come from our software, from Standby Multi-Platform. Excuse me. This limit is configurable. We've actually found that it doesn't need to be configured all that often. 10 seems to work pretty well irrespective of hardware. Whether you're running a very powerful server or not, 10 seems to work pretty well. And what this allows us to do is in our real-time dashboard, even if you have hundreds of configurations, you are now able to select the vast majority of them, issue some relatively heavy-duty action, for example, doing a differential sync, a differential synchronization, right? That's a relatively performance-intensive action. And no one instance is ever overloaded. And what that means is that the systems don't bog down, our dashboard doesn't bog down. You can one click to perform a very large number of actions, and then just kind of sit back and watch it happen. And it might take a while, right? It might take a whole day, but it doesn't bottleneck, that the system doesn't experience artificial slowdowns. So again, just one more way that we're moving towards that kind of larger scale deployment scenario. We've introduced support for SQL Server native backup compression. So some of you will, I'm sure, know that SQL Server has a feature built into the product itself to compress backups of all kinds, either full backups, differentials, or even the transaction log backups as well. Not all SQL Server versions support this, so Standard Edition and Enterprise Edition support it, as some of the others don't, I think. But the good news is that if your SQL Server version supports this, so do we now. So we've got a new a page in our backup settings menu, and that allows you to select what type of backup you would like to be compressed and to set the settings for doing that. Depending on the type of data in your database, this could be very important. So if you're storing data that is easily compressible, again, text data, non-binary data, this could save you a lot of disk space. It also plays well with some of our other features. So for example, we've already for a while now had a feature that allows you to set a log backup retention period on both primary and standby. So what that means is you can say, right, even though a log was successfully shipped and restored onto standby, I still want to keep it there, for whatever purposes you may have. There's lots of reasons why you might want to do that. And if you are doing that, obviously the number of logs building up on standby is going to impact your available disk space pretty quickly. So if you're able to compress them effectively using this feature, you can keep a much longer backlog without having to add additional drives. We've also made many improvements for parallel disk actions. So this has actually been the biggest time spent for us with this version. As I said, our SQL Server business grew a lot this year, and together with that, we've received a lot of feedback, technical feedback from our partners and from our users on some really quite complex edge cases and situations where there are a lot of things on a system competing for SQL Server's attention. So sometimes we found that in combinations of multiple concurrent file operations, nothing to do with our software, by the way. Once again, we're talking about things like various applications that may be utilizing database files, antivirus software, or cybersecurity software that's got its tentacles in everywhere, keeping track of things. Various I/O operations, basically, that are happening concurrently with SQL Server's own actions. In some complex edge cases, we saw that operations on the database, on the instance, could slow down or even just fail outright, and it would always be intermittent. It would depend on the planets aligning or misaligning, if you like. So we've done quite a lot of work in trying to mimic a whole bunch of edge case scenarios and introducing ways to mitigate these intermittent errors. So whether that's retry logic, this seems to be a thing on Windows. Windows sometimes really doesn't like to let go of file handlers, even though it really should. Retry logic in cases where the failure's apparently unavoidable, we've gone through and we've really improved our error messaging for being incredibly detailed as to exactly which file system level operation failed, just to give our expert support team and your system administration team the maximum possible information to go on for resolving the problem. And we also improved our state tracking. So whenever you launch any action in Standby multi-platform, you get kind of like a task preview with various steps in it that we're running. So the most simple case, if you're, for example, creating a Standby database, very roughly what that means is taking a full backup, shipping the backup, restoring the full backup. Right? I'm simplifying, but that's an example. So we've added more states into those tasks so that as our product goes through that logic, if something does go wrong or if something takes longer than it should, you get very, very accurate feedback as to exactly which step failed or is taking too long and exactly why. And the point of all this is, again, we want to make sure that our product is your best choice for managing complex environments. Log shipping that's built into SQL Server, native log shipping, is sometimes treated as, rather unfairly, I think, is sometimes treated as like a poor man's DR tool, and I don't think it is. I think it can be very appropriate in many cases, but it's kind of, it lacks a lot of clarity. It lacks a lot of options for giving you the information you need to manage complex environments. And if you go into availability groups, it's kind of the same but different. On the one hand, things tend to go smoother during setup, but then it's actually even harder to kind of remediate problems when they come up, because what's actually happening behind the scenes, now especially that failover clustering is in the picture, it can be even harder to figure out. So if you've got dozens of availability groups running in all directions, sometimes it can drive you crazy. And what we're trying to do is we're trying to get to a point where our product is your golden standard for managing these environments where you have a lot of things going in various directions. Inevitably, sometimes they'll go wrong. And when they do, you really want to be able to track down exactly what happened so it doesn't happen again. And last but not least for this list, we've gone through, this was a fun manual task. We've gone through and we've got rid of a whole bunch of extraneous logging and tracing. So in dbvisit, we like to err on the side of caution for debug information. And our trace files and our log files tend to be quite extensive. We like to log perhaps a little bit more than is strictly necessary, just because when we do go through something together with a client, we like to make sure that we've got everything we need to solve the problem. And we've been doing this for 20 years, so we'd like to think we know where the line is between logging everything we can and not slowing things down. But we went through and we found a number of edge cases where in slightly unusual situations, for example, if you have a large number of instances and at some point the automatic log shipping had failed, right? So for example, the log files were being backed up and they were being sent across, but they weren't being applied and they just kept piling up on standby. And that was never resolved. So on the standby side, the log backups just keep piling up, time gaps growing and growing, and it wasn't resolved. If that carries on for an extended period of time, we found that we would generate a very large number of debug messages, just due to various cycles in our product logic that would try to figure it all out. And those weren't necessarily useful. They were just taking up space. So we found a number of such scenarios. That's just an example. We found a number of such scenarios and we removed them all because at the end of the day, the point of all these debug logs is to help us and help you save time on fixing problems. It's not to maximize your file I/O, especially when you're dealing with hundreds of configurations potentially at a time. So with all these changes, who can best benefit from standby multi-platform for SQL Server, especially from this version forward? Just wanted to kind of give us a quick refresher on who we're targeting all this for. What is this work ultimately about? And there are three main targets in our opinion. The first is new users to SQL Server. So SQL Server is growing in popularity. There's a large number of companies that are slowly moving into it from other database platforms, Oracle certainly being one of them. And sometimes these people, these companies, these DBAs on some occasions, they're well aware of the requirement for disaster recovery, right? You often don't have to explain the importance of disaster recovery to them. They know it perfectly well. But when they try to actually set this up, when they try to actually set up Windows failover clustering and try to configure an availability group, and they try to troubleshoot it when it goes wrong, and they try to set up all the different disparate jobs for log shipping through Management Studio, the learning curve is just a little bit too high, and the clarity is just a little bit too low. They want something easier to use. They might not have the most complex use case in the world, but they want to make sure that whatever they've got works and they understand it. And our product is the perfect fit for that. You can install Standby multi-platform for SQL Server in a few minutes and have it going a few minutes after that. So anyone who's new to SQL Server, we're a great fit. The second use case is DBAs that are very busy. So the truth is that some things you just can't get out of native tools. If you, for example, if you're dealing with a very busy production instance with hundreds of databases or dozens of databases, and your production team likes, for example, provisioning new databases without telling you, 2 weeks later you do a little revision and you find that there are 4 production databases that have never had a standby created because no one mentioned it to you. So we have a feature called automatic standby creation. This is just an example. We have several such features. We have a feature called automatic standby creation that allows you to basically create an instance relationship and say, right, this is the primary instance, this is the standby instance. Whenever a database appears on the primary instance, can you please automatically create the standby equivalent, create the standby database, set up automated log shipping, set up monitoring, get it all going completely autonomously, without the DBA even having to approve anything, without having to click a single button. Now, stuff like that you just can't get out of native tools, and you very, very rarely can get anything like that out of, for example, cloud tools as well. This is stuff that is advanced functionality on the SQL Server database itself. And so when one of our most interesting sales last year was a relatively small company that only had a single senior DBA, and he was just run off his feet with all the things he had to manage. And his problem was that he just wanted more automation. He wanted more automation in a way he could understand. And that's exactly what our product provides. So if if you already have a SQL Server deployment and you've already got SQL Server DR, but you're just finding it a little bit too annoying to manage, give us a look. Our webpage, I think, does on SQL Server does a good job of explaining some of this. And last but not least, and really what this 12.3 version was targeted at, is DBAs managing outsized SQL Server environments. So as I said at the beginning, there's a huge difference between managing 3 instances and managing 300 instances. If you're managing 2 instances with 20 databases between them, it's not the end of the world to go into Management Studio and just manually check what's going on, right? Or to set up a simple script that just sends you a heartbeat email. That's completely understandable. The moment you're dealing with dozens or hundreds of databases across multiple instances, this does become a problem. And so things like a real-time dashboard, things like not having to deal with file management, not having to clean up transaction logs, and not having to worry about data retention on primary and standby separate to each other, not having to update jobs in multiple systems every time you want to do a switchover, becomes a big deal. If you want to switch over 25 databases simultaneously for maintenance or patching, you want to make sure that everything follows along with them. You don't have to clean anything up, and then you want to switch them back just as easily. This is what our product is targeted at. So the changes in 12.3 specifically are very much aimed at getting standby multi-platform for SQL Server to the point where it's a genuine enterprise level tool for large scale deployments. We've had some brilliant pilot customers doing this. And if that's your scenario, your situation, I encourage you to take a look as well. So I think we've got a couple of questions. Let's have a look. First question is just about faster DR creation through optimized query batching. So what I was referring to there is basically the I mentioned it's kind of inherent in a couple of the things I mentioned as points as we went to the points for 12.3. One of the other improvements we did is previously, whenever you would multi-select things in our dashboard and select some action, for example, differential synchronization. If you selected 100 databases and did a sync, we would issue 100 separate tasks, if you like. So it would be 100 separate objects that would then propagate through our system that would create an action on the instance, et cetera, et cetera. Now we've introduced query batching, where basically whenever you select multiple databases on the same instance for a same action, or actions that are related in some way, we're clever enough now to batch those into a single query, into single commands, into single objects in our state engine. And what all that means is that everything is just a lot less verbose. Everything works faster, not because we're doing fundamentally anything new, but just because we're optimizing all the information flow in and out of SQL Server. And the second question, again, about multi-database actions, auto standby creation, I think we've already covered those. So a follow-up to that we have in QA is, are these points also for Oracle and Postgres? So everything to do with optimization, query batching, with optimization of commands from our software, yes, this also affects Oracle and PostgreSQL. So if this is something of interest to you on those platforms, absolutely, 12.3 is a very important release. Some features, such as what you mentioned, for example, auto standby creation. So auto standby creation is SQL Server specific, just because SQL Server is the only platform that allows for multiple databases in an instance. Other features, other automation features, for example, our monitoring solution, our observer and automatic failover feature, that again is across SQL Server and Oracle and Postgres. So depending on which one you're interested in, I would encourage you to either check out our website or get in touch with me. I'm sure you'll have my information as a follow-up to this webinar, and I'll be very happy to talk you through it. Another question we've got is there any limit to the number of configurations supported in the console? So say there are 200 plus databases across Oracle, SQL Server, and Postgres. So there's no hard limit. You can have any number you like. We have tested 12.3 all the way up to about 400 configurations. That's as far as our test setups went across multiple database platforms, just as you say. And it works really well with no appreciable performance overhead on systems as well. So the short answer is no, there's no limit. If you're considering our product for a large-scale deployment, you're very welcome to do so. We're going to stand behind you. 97% customer satisfaction, don't forget. If you've got details on that, by the way, again, please do reach out. I'd love to work with you to make it happen. Another question: what's the safest upgrade approach to 12.3? So there's nothing special about upgrading to 12.3 compared to any other version. The way that we always deal with upgrades in dbVisit is we allow you to basically upgrade from any version to any version within a major version release. So what I mean by that is within version 12, you can upgrade from version 12.0 or 12.1 to 12.3, or when we release it 12.4 or anything in between. And the way you do that is just a straight. You don't have to redo anything. You just download the latest version of our website. You always have the latest version available to you for free as long as your support contract with us is up to date. And you run your installer as per usual. All it does is it shuts down your services, updates your files, restarts your services. That's it. You don't even need to reconfigure anything. So that's the way we've been doing upgrades since version 7, I think. And nothing's changed. So if you wanted to go to 12.3, all you have to do is download it from our website. It's available now. And put the installation module on every system you've got. So that means every database server plus the control center, and run the installer just like you originally did. I think those are all the questions we've got. So thank you very much, everyone. That's good. It's good to see questions coming in. Once again, I urge you to give it a go. It really is, it being the product, is really a great solution for SQL Server large-scale deployments now. We're continually building on it. It's looking really good. The customers that we already have on it seem to be very happy, and it's something that we're committed to building on in the future. If you've got a complex requirement in mind, please reach out to me. I'd love to work with you. Otherwise, hope you have a great day. I hope you consider working with us, and I'll speak to you again real soon.